Okay, so this is a factorial, and basically what factorials are is if you take a number n which is greater than 0 or equal to 0, it's going to multiply every number before it until it gets to 0. So for example, let's say n equals 4 factorial. That's basically saying 4 times 3 times 2 and then times 1 and then that's the last number before 0. That's equal to 4 factorial. So it's basically simplifying the multiplication of every number before it. So if we were to evaluate this, you just multiply everything. So 4 times 3 is 12, and 12 times 2 is 24, and then 24 times 1 is just 24. So it's equal to 24. And let's say we have another example like 6 factorial. It would be the same thing. We would just do 6 times 5 times 4 times 3 times 2 and then times 1. So this is 30. So 30 times 4 is 120, and then 120 times 3 is 360, and then times 2 is 720, and then times 1. So we'll just keep it at that. So that's basically what a factorial is. Okay, so now let's use factorials to simplify an expression. So here we have 6 factorial plus 5 factorial minus 4 factorial, all divided by 4 factorial. So first, some people might think that 6 factorial plus 5 factorial equals 11, but you can't do that. You can't just add the factorials up like that. So what we can do though is split up each factorial. So we know 6 factorial is equal to 5 times 4 times 3 times 2, 6 times 2 times 1. So we can take this right here, this 4 factorial, or this 4 times 3 times 2 times 1, and just say that's 4 factorial because that's the same. It's 4 times 3 times 2 times 1. And we're just left with 6 times 5 times 4 factorial. And then now we can do the same thing with 5 factorial here. So 5 factorial equals 5 times 4 times 3 times 2 times 1. So we can just take this here and say it's 4 factorial and then 5 times. So now let's put both of them back in. So now we have 6 times 5 times 4 factorial, and then that's the first term, plus 5 times 4 factorial, and then we're left with minus 4 factorial on the numerator, and then all that's divided by 4 factorial. So now, on the numerator, we have a common term, which is 4 factorial, so we can take that out of every term. So we can just say 4 factorial times 6 times 5 is 30, plus, and then you just left with 5 here, and then minus 4 factorial, which is just 1. And then all that's divided by 4 factorial. And then we see on the numerator and denominator, we have the same thing. So we can just cancel these out. And we're left with 30 plus 5 minus 1 equals 34. So that's the simplified version of that expression. Okay, so the next factorial or expression we have is n factorial minus n minus 1 factorial divided by n minus 1. So this doesn't have any numbers other than the 1. So we can still simplify it though using the same method. So if we have n factorial, we can just write this as n times n minus 1 factorial. And then n minus 1 factorial is the same thing as n minus 1 times n minus 2 times n minus 3, and forever. So if we put this back into the expression, we'll have n times n minus 1 factorial, and then minus n minus 1 factorial, and then all that's divided by n minus 1. So on the top we have, in the same terms, we have n minus 1 factorial. So if we take that out, we'll just take that, if we take that out, we'll have n minus 1 factorial times, and then if you take this out, we'll just have n in the first term. And then if you take out n minus 1, since there's a negative here, or minus, we'll just have minus 1. This is in the same term actually. Okay, so, and then all that's divided by n minus 1. And you see here we have the same two terms, n minus 1 and n minus 1. So if we cancel that out, we'll just have n minus 1 factorial. And that's a simplified version of that expression. Okay, so last example we have is n plus 2 factorial plus n plus 1 factorial, all divided by n plus 3. So here we can simplify this or expand this a little. So n plus 2 factorial, is the same as n plus 2 times n plus 1 factorial. It's n plus 1, we decrease 1 because when we have n factorial, we do n minus 1. So 2 minus 1 is just 1. And also, don't forget the factorial. So if we put this into this equation here, we'll have n plus 2 times n plus 1 factorial plus n plus 1 factorial all over n plus 3. And on the numerator, again, we have n plus 1 factorial which on the same on both terms. So if we take it out, we have n plus 1 factorial times n plus 2 plus, and since we took this out, this is just left as 1. So n plus 2 plus 1 all over n plus 3. And since this is also n plus 3, we also have that on the bottom, so we can take these both off. And this is just equal to n plus 1 factorial.